Hello students, welcome to Infinity Learn NEET YouTube channel. This is Suresh, Faculty of Chemistry. Today I am going to present to you the pH calculations, a very important topic for the NEET examination. Definitely you can expect one question from your question paper and it carries 4 marks, and let us discuss about the pH calculations in all variations. What is this? So for an acid to say, the acid is a substance which donate H plus ion to the solution. So how much H plus ion is there, that is the power of an acid. Similarly, the base, you can say the base is a substance which donate OH minus ion into the aqueous solution. More OH minus, more is the strength of the base. So how much H plus is there, how much OH minus is there, that is measured by using a scale, that is what you can say pH scale. This pH scale is given by Sorensen. It is nothing but negative logarithm to the base 10 of H plus ion concentration, that you can say hydronium ion concentration, and pH is equal to negative logarithm to the base 10 of H plus ion activity. And this scale is going to be free H plus ions. How many are there in the aqueous solutions? It can be, scale is 0 to 14, 0 to 7, 0 to 6 is said to be an acid, and 7 is said to be base and neutral, and greater than 7 is said to be a base. That is given by this pH scale like this. So 7 is said to be neutral, and less than 7 is said to be acidic, and more than 7 is said to be a basic. So we will check what is the pH calculation strategy that is useful for this NEET examination. Get ready. So the pH is equal to negative logarithm to the base 10 of H plus, or you can say pH is equal to log 1 by H plus ion concentration. Otherwise I can say pH is equal to negative logarithm to the base 10 of H plus ion concentration. pH is equal to negative logarithm to the base 10 of H plus ion concentration, and H plus ion concentration is equal to 10 to the power of minus pH. And pH is, can also be said that negative logarithm to the base 10 of H3O plus ion concentration, and POH is the same, is equal to negative logarithm to the base 10 of OH minus ion concentration, and POH is also said to be log 1 by OH minus ion concentration. And you know that ionic product of water Kw is equal to the product of H plus ion concentration and OH minus ion concentration, that is equal to 10 power minus 14 mole square liter square. This is valid only at 25 degrees centigrade. You can take negative logarithm to the either sides, and you are going to get negative log H plus minus negative log OH minus is going to negative log 10 power minus 14, and it is going to be negative log Kw, which is equal to 14, and negative log H plus is equal to pH, negative log OH minus is equal to POH, and is equal to pKw is going to be 14. You can use this expression for an aqueous solution at 25 degrees centigrade. And moving ahead, if the temperature of the solvent is changed, you say pH is equal to 7 is a neutral. This is only valid at 25 degrees centigrade. What happens if temperature is changed? Kw changes. As Kw changes, pH value is going to be changed. So you can say the pH value 0 to 14 is said to be the scale at 25 degrees centigrade is validated, and if temperature is changed, it is going to be changed. But the acidic and basic nature of the water do not change. 0 to 14 at 25 degrees centigrade, neutral pH is going to be 7. If temperature is raised, let us say this, as temperature is raised, Kw value increases. So it changes from minus 10 power 14 to 10 power 13, and negative neutral point, the pH is going to be 6.5. I just want to say, as as temperature increases, pH decreases, but the acidity and the basicity and the neutrality never changes, mind it. And also you can say pH can also be negative or greater than 14. That is actually the defect of in the pH scale given by Sorensen. And let's talk about pH is equal to 7, pH is equal to negative log H plus is equal to 7, pH is equal to negative log OH minus is equal to 7. For water at 25 degrees centigrade, it is measured experimentally and it is true, and it is true only at 25 degrees centigrade. If pH is greater than 7, it is a basic. pH is less than 7, it is going to be acidic. And pH calculation strategy के बारे में आपको बताने वाला है, and you follow this and you can expect a very good score from your NEET examination. First of all, let us talk about the strong acidic solution. Whenever the strong acidic solution, check whether the solution is a diluted solution or a non-diluted solution. If this concentration is less than 10 power minus 6, it is said to be a very diluted solution. If 10 to the power 6 or more than that, it is said to be a normal solution. For a normal solution, H plus ion concentration is going to be the normality of the acid. Whereas if the concentration of the acid is less than 10 power minus 6, you have to take the ionization of the water. So H plus ion coming from the water also you have to consider, so that this H plus ion concentration of the acid is total is equal to H plus ion concentration from the acid, as well as we have to take the H plus ion concentration by the self autoprotolysis of the water. Similarly, for the strong bases, you have to take the OH minus ion concentration. In the same parameters, we have to consider if it is a less than minus 6, 10 power minus 6, you have to take the base concentration, and if it is less than that, you have to take the base concentration as well as water ionization constant, and also if it is a greater than this, only you can take the OH minus ion concentration from the base concentration. From there you can calculate POH is equal to negative logarithm to the base 10 of OH minus ion concentration. As we know, pH plus POH is equal to 14. So pH can be calculated by subtracting from the 14 by the POH you calculated so far. So that is the basic difference between the pH calculations you made with a strong acid and a strong base. So let us talk about if it is a mixture, strong acid and a strong acid, two strong acids are mixed. Let us say normality of one strong acid is NX and its volume is Vx, and normality of another strong acid is NY and the volume is going to be NY. So the total H plus ion concentration is going to be NX YX plus NY YY and volume of X plus volume of Y. That's it. So from this H plus ion concentration, total is going to be taken by the pH is equal to negative logarithm to the base 10 of H plus ion concentration total you have taken. So from there you can calculate the pH of the strong acids. Similarly, strong bases, if it is a strong base and a strong base is mixed, we have to take its normality of the strong base. Okay, this is said to be again NX Vx and it is going to be NY Vy. So NX is the normality of a base, strong base X, and Y is the normality of the strong base Y. So total OH minus ion concentrations can be calculated based on NX Yx plus NY Vy upon Vx plus Vy. So from there you can calculate a POH can be negative logarithm to the base 10 of OH minus ion concentration and followed by pH is equal to 14 minus POH. Directly you will get the answer. So this is one combination. If one strong acid and one strong base is mixed, so what is going to be the scenario? So let us say strong acid is normality of a strong acid, volume of a strong acid, normality of strong base, volume of the strong base. In the case 1, if NaVa is equal to Nb and Vb, so total strong acid is neutralized by total strong base. So there will be the solution is going to be neutral. resultant solution is going to be neutral. Once it is in neutral, the pH is going to be 7. If something is greater or something is less, what we can do? So this is the techniques you need to learn for this NEET examination preparation. Let's say case 2. So if this is the case, normality of acid, volume of an acid is greater than normality of base and volume of base. So in this case, acid is more as compared to number of equivalents of an acid is greater than number of equivalents of a base. If that is the case, the solution is acidic. For that you need to calculate H plus ion concentration resultant is equal to Na Va minus Nb Vb upon Va plus Vb. From this H plus ion concentration you can calculate pH is equal to negative logarithm to the base 10 of H plus ion concentration. You can take it. So this is the second case. Let us go with the third case. It's very interesting here in this third case. If Na Va is less than Nb Vb. So base concentration is more, number of equivalents of base is more than number of equivalents of an acid, so that the solution is going to be basic. If the solution is basic, OH minus ion concentration can be calculated by using Nb Vb minus Na Va upon Va plus Vb. So once you got OH minus ion concentration, you can calculate POH is equal to negative logarithm to the base 10 of OH minus ion concentration, and the pH can be calculated subtracting from 14. So this is how the strong acid and the strong bases mixtures can be calculated. Let us go ahead with the weak acid or a weak base. So how do you do the weak acid? Because weak acid do not actually ionize. So as it is do not ionizing, you can calculate by using a simple, let us say CH3, COOH is a weak acid, monoprotic acid gives rise CH3, COO minus and H plus. As this is ionizing at equilibrium, let us say initially it is going to be C moles per liter 0, 0, C minus C alpha. Alpha is the degree of ionization. It is going to be C alpha and C alpha. So in this case, Ka is equal to C alpha and C alpha upon C of 1 minus alpha. So C alpha square upon 1 minus alpha. This is the Ka, acid dissociation constant formula from the Oswald dilution law. And you can also calculate the H plus ion concentration here is equal to C alpha. From this, if this value is ignored, Ka is nearly equal to C alpha square. So that alpha is equal to root Ka by C, and H plus is going to be C dot root Ka by C. So H plus ion concentration is equal to root Ka dot C. So from there you can take the negative logarithm and you can calculate the pH directly from this. I just want to say pH is equal to half pKa minus log C. This is a powerful formula that you can directly calculate the pH of the weak acid. Similarly, you have the weak acids and as well as weak bases. You can calculate weak bases is going to be POH is equal to of pKb minus log C. C stands for concentration and Kb stands for a base dissociation constant. From there you can calculate pH by taking the subtraction from the 14. And let us quickly discuss in the short 10 minutes video how to calculate the pH. pH can be calculated. If you find the pH of 10 power minus 3 molar HNO3, you can calculate directly taking the H plus ion concentration. HNO3 gives rise H plus NO3 minus. So H plus ion concentration is equal to molarity of the HNO3, so that it is taken as a negative logarithm to the base 10 of 10 power minus 3, it is equal to 3. If it is a polyprotic acid, strong acid, so let us take H2SO4 into this consideration. Here H2SO4 ionizes 2 gives rise 2H plus SO4 2 minus. In that case, H plus ion concentration is the double the concentration molarity of H2SO4. That's the reason why it is given as 10 power minus 4. This 10 power minus 4 is multiplied with 2, so that you are going to get a negative logarithm 2 into 10 power minus 4. So 4 minus log 2. So log 2 is equal to 0.3. So 4 minus 0.3 is equal to 3.7 is the answer for this question. So simple version of the calculation of the pH. And also you can take what is the pH of a strong base. If that is a strong base, first you calculate the pOH and subtract it from 14, so that you are going to get from strong base you can take OH minus and concentration, because barium hydroxide is going to be ionized like this, gives rise to barium 2 plus and 2 OH minus ions. So the OH minus ion concentration 2 into the given concentration, from there you calculated the pOH, and from the pOH you are going to see 14 minus that pOH is going to be the answer for this question. Simple, and you need to know the methodology to calculate. And also let us go for this mixture. All varieties of the pH calculations I am just presenting. You follow this, and 400 milliliters of 1 by 200 molar H2SO4, 400 milliliters of 1 by 100 molar HCl, for that little bit of 200 milliliters of water is also added. So it is a mixture. When it's go for this mixture, H1V1 is calculated. This is H1V1, and H2V2 is calculated, and 200 ml of water is also added, and H1V1 plus H2V2 is diluted, so that total volume is going to be 1 liter, and from there H plus final is going to be this much, 8 into 10 power minus 3 molar. From this you can calculate the pH is equal to negative logarithm to the base 10 of 8 into 10 power minus 3, so that 3 minus log 8, so it is going to be 2.1 is the answer for this question. And also let us see the calculate the pH of the weak acid depending upon the concentration. The weak acid calculations should be dependent, it's very important. So calculate 10 power minus 1 molar CH3COOH. If that is the case, it is okay, is not too diluted. If it is too diluted, next methodology you have to use, I am going to say. So from there Ka value you have to take in 2 into 10 power minus 5, the question itself is given. And alpha is equal root Ka by C, and Ka is acid dissociation constant, C is the molarity. According to Oswald dilution law, you have directly taken alpha value, and H plus ion given as a C alpha. C is given as this much, and alpha value is given as this much, and you can directly put the pH value is equal to 2.85. And more precisely you have to go with if the concentration is very less. Take one more example. If the concentration is less, the same way calculate the pH of 10 power minus 3 molar CH3COOH, where this concentration is given very less. You need to be more precise here. Alpha is equal to is greater than 0.1, so that we need to go for some granular level of calculation, kind of we have to do the exact calculation like that. K is equal to C alpha square by 1 minus alpha. In the previous calculation 1 minus alpha is ignored. Here you need not have to ignore, you have to consider it. So by taking this, alpha is calculated to be 13.14, and from here H plus is going to be 10 power minus 3 C alpha. That is alpha value 13.14 means 0.1314. By taking this, pH is equal to 3.8. Okay, as concentration changes, the pH is changed for the weak acids. Okay, today we discussed about what is pH scale and how many types of pH calculations we can do for the combination of strong acid and strong base, and a mixture of strong acid and strong base, and weak acids. and stay tuned with this Infinity Learn NEET YouTube channel. Some more varieties of calculations you are going to get in the future classes. Please like and share and subscribe this session. Thank you very much.